of you who are like, Oxa, what? What are you talking about? All right, let's talk about it. What are oxalates, Monique? Hit it. Tell
Well,
us.
actually, they're a very simple chemical, a couple of carbons, a few oxygen atoms, and who knew they could make so much trouble for us in our bodies? So, why don't I give a little bit of context so that people have kind of a background? Oxalate is something that you generally find in plant foods. You don't generally find it in animal foods. And unfortunately, it is very healthy for plants. It is not necessarily very healthy for us. So, plants use it for all kinds of great reasons. They use it to handle oxidative stress situations like tough growing conditions. They use it for enhancing their ability to get the biggest bang for the buck out of sunshine. Like they are doing it for lots of things. Oh, and they're also doing it to defend themselves. So, oxalate's toxic enough and damaging enough that plants like spinach are using oxalate to protect them from predation. So when insects try to eat a spinach leaf, that distinctive sort of gritty taste in your teeth, that's actually oxalate crystals, and that will break up the mouth of the insect trying to eat the leaf. So spinach and some other plants have found ways to defend themselves with oxalate. So that's all part of the
I
biochemistry of
used
your
to think
plant.
that was dirt.
No, that's the gritty crystals in the spinach.
Oh my
Yep.
goodness.
Plants actually also use oxalate to pull up minerals into the structure because oxalate's a mineral chelator. So some people may have heard of that in the context of heavy metals and things like that. Chelation is a way that the plant then is able to get minerals out of the soil. So it's using oxalate to chelate that mineral, bind with it essentially, pull it up into the plant, and then the plant has the metabolic pathways to snip those apart. So it can remove the oxalate from the mineral and then use it. The problem for
Very
us is that we do not have those pathways. So we can't do any or all of those things. And while we do produce a certain amount of oxalate naturally, so people will say to me, well, we produce oxalate, so it must be good for us. No, no, no. Metabolic end product, not recyclable or reusable by our system. It is a mineral chelator. It's going to deplete us of minerals. It's a mitochondrial toxin. That's not a happy thing either. And in fact, oxalate competes with certain nutrients we really do need for uptake into cells. And that's a little bit like trying to use monopoly money to buy something at a store. The cell pulls up oxalate when it's trying to use something like sulfate or bicarbonate or chloride. It won't be able to do anything with the oxalate. The reason that becomes a problem is that it'll kind of accumulate in the cell. So the cell will choose not to use energy to get rid of the oxalate it just pulled in. The cell transporter essentially drops it, and then the cell uses its energy to send a cell transporter out again to try and get what it wanted, what it needed. And so we can end up with kind of the equivalent of an overflowing garbage can in the corner of your cell that is also toxic, is also binding to minerals, is also driving inflammation. None of these are good things. We do not want this stuff in our cells, but that's where it can end up if we've got too much.
Yeah, so you basically answer the question two and three here about how the body process and eliminate it, and also are they always harmful? Sounds like they pretty much are, correct?
Well, it's a matter of the poisons in the dose. I hate to use that old expression, but a little bit of oxalate, our body knows what to do with because we do produce a certain amount out of our metabolism and our body knows we need to move that out. The problem is if it's not in the bloodstream, the mechanisms by which the body can move it out are not present. If it's inside the cell, it can be kind of stuck there for a while. So we move it in and out of cells with cell transporters. That takes energy. So the cell's not going to do this process until it's got the energy to do it. And then we move it out of the bloodstream into the kidneys or other pathways to get rid of it by secretion. And that also takes energy. So the body's not going to do that unless it has enough. So because it takes energy to get rid of it, it's not just a passive, simple, oh, it turns up in the bloodstream. It passively diffuses into the kidneys, who passively diffuse it into urine. There's energy expended at every step. And so that can cause us some difficulties in terms of getting rid of it if we're exceeding our bandwidth for how fast we can normally process it.